Good morning, everyone. It's really nice to be somewhere where the word translational research is not a dirty word. So that gives you a little bit of the background. So who am I and why am I here? I think as Melissa introduced me, I'm the CEO, president of the Wallace Coulter Foundation, but that doesn't really explain it all. So who was Wallace Coulter and what is his foundation? I guarantee that each and every one of you have benefited from Wallace's invention, the Coulter Principle, because his Coulter counter is like the Kleenex, like the Xerox, in reference to medical diagnostics. So I just want to explain a little bit about the Coulter Principle. The biggest use of it is in blood cell automation, automated hematology. He revolutionized medicine as we know it in the doctor and patient relationship. As you know, it doesn't really matter if you have a headache or a broken leg or whatever. You go to the doctor, what do? Blood test. So the blood test comes first before you can get specialized testing in cancers or infectious diseases or in anything. But most people don't recognize that the Coulter Principle is also responsible for the gold reference method in manufacturing of over 500 consumer products. So like I said, each and every one of you, your families, have all benefited from Wallace's invention. So a little bit about the company. We were a private company for 40 years, and it is quite different to work in a public company versus a private company. First, you don't have a whole lot of investors, so you have to create your operating income and investments internally. You don't have a lot of stakeholders, so there's not that many people telling you what to do and how to use your money. So you do have the freedom to watch out for your employees and to watch out for the customers. So as a private company, we had a long-term strategy. The goal was to keep it in the family for as long as we could. So reference to major R&D investment, most companies invest 8 to 12% on research and development. Our company invested over 20% in research and development. And that was because we didn't have shareholders, we didn't have bankers, we didn't have other investors. That kind of technology thinking lets you invest long-term, lets you have a vision for what you really want to do, which is to cure the human condition. So as an example, we invested in cytometry, flow cytometry. It was basically a Coulter counter. And we invested in it for 13 years without a return. And most companies are not going to do that. So distribution channels, when we talk about the best products, you can have the best products, but if you cannot get it to your customer, it doesn't really matter. At the end of the day, Wallace was not only an inventor, an entrepreneur, innovator, he understood marketing. And at the very, very beginning, when he launched his company with the patent in 1953, he started building distribution channels around the world. In fact, we had a Coulter Australia, and I visited in 1982. System sales, because we were private and we had to generate our own operating income, one of the things we pioneered around the world was to sell our products as one system. It wasn't just the fact that we would have equipment. We would have the equipment, we would have the consumables, we would have the reagents, all packaged up in a system sale. That kind of marketing strategy helped us be #1 for over 50 years, way long after a patent expired. Because when you bought from Coulter, you had it all as a one-stop shop. In reference to worldwide leasing, as you know, leasing is a financing tool. We converted leasing to a worldwide marketing tool. So every 4 years, we would sign customers up for 5 years. Every 4 years, we would go in and renew the lease. It was very, very hard for a competitor to take out Coulter. That just to give you an idea of the company. It was owned by 2 brothers, Joseph and Wallace Coulter, from the beginning to the end. So this shows you the medical application. Everybody knows when you get a blood test, you see these purple tubes. Okay. Flow cytometry, particle characterization. And the industrial applications, like I was saying, the 500 consumer products. If you drink wine, if you drink beer, if you drink milk, if you have Bailey's Irish Cream, you have chocolate, you have prescription pills, you have cosmetic powder, moon dust, all of those products are quality controlled by the Coulter counter in their manufacturing process. So, how did the foundation get established? Unfortunately, both brothers, one younger brother passed away in November '95, and it's been medically proven that when you have someone that's very close, children, spouse, siblings, that probably you will lose the other one within 18 to 24 months. So when his brother passed away, we had a very big challenge to try to preserve the company the best we could, take care of our customers, take care of our employees, so we had to sell the company. And the sale was consummated in 1997. That was actually my last trip to Coulter, Australia, to explain why the company was being sold, how it would impact everyone, and how Coulter Australia in particular would be impacted. But the most important news I had to bring was that Coulter was going to leave $100 million on the table to be shared by every employee and every subsidiary around the world for their service to the Coulter family. So that was why I came in 1997. So the foundation is a continuation of Wallace's long life passions. And what does that really mean? Well, because we're a private company, we had to come up with ways to operate our company from our own investments, from our own return on capital. So we were pretty entrepreneurial and pretty risk-taking in some of the pioneering actions that we took, as you heard from before. We were the first company, and probably the only company, that used a leveraged buyout to buy a Japanese company in Japan. So many things like entrepreneurism, innovation, to be candid, is available everywhere. It doesn't have to be in science, it can be in business, it can be in everything you do. Can you do it a better way? And because we had no capital investors, we had to invest in partnerships. Our partnership with our customers, partnership with our employees, our partnership with our vendors, our partnership with our bankers around the world that finance our international subsidiaries. That's how we operated. And because this foundation has a short life, because I will be sunsetting in around 2025, we had to achieve excellence and impact in a relatively short time. This is not a perpetual foundation because I am the sole trustee. Therefore, in order to have excellence and impact, you really have to take some risks and be entrepreneurial in foundation philanthropy. So let me share with you a couple of the programs. To continue Wallace's legacy, Coulter was more than 50% international. Most companies do everything possible to have a global market. We were global from the beginning because we set up subsidiaries in 20 countries around the world before most companies did so. So in our biomedical societies, one of them is the American Society of Hematology. When they have an annual conference, they almost have 25,000 people attending. But their international membership was low. So we gave them the risk capital to do their conferences in places that they had never gone to, in China, in Latin America, because at the end of the day, the American societies still have probably some of the best and brightest research talent, medical, technical information, and until and unless people take that kind of technology or standard of care to less resource country, as you heard before, we cannot do it alone. We have to share, and we have to bring up the standard of living in other countries the best we can. The Special Opportunity Fund, sometimes there are tragedies, but we try to make those tragedies into opportunities. As an example, in Katrina, Hurricane Katrina that impacted the state of Louisiana for just basically for a long, long time, the people were really devastated. We chose to support two historically black colleges, Xavier and Dillard, because we felt that they probably would not get the financial assistance they needed. We funded their laboratories. We gave each organization $2.5 million to be able to bring the laboratories so that the students could come back, so that the faculty would be able to be teaching again. The Asian American Initiative, in America, there's about 20 million Asian Americans. And I have to say, too, the term Asian America would only work in America. It's an innovation in entrepreneurship in the title itself, because you have over 50 different ethnicities and over 100 different dialects, some of them who have been war with each other for decades, maybe centuries, actually working under the title of Asian America. Therefore, this community, because it's been fragmented, had not been supported by foundation philanthropy, and it only receives about 0.3% of foundation philanthropy, which is in the billions of dollars. So Coulter Foundation has become the biggest supporter for this community, and we are trying to educate and train and provide opportunities for civic engagement, because unless and until your citizens become fully engaged in civic engagement, then they are not fully vested in the country, and they will not be giving back. So our goal is to help everybody get the American dream. And the last program is the reason that I am here. I met Melissa about 2001 when we endowed the Georgia Tech and Emory Biomedical Engineering School with the Wallace Coulter Award in Innovation and Entrepreneurship. And she applied. And she was explaining to me how, in order to get through security with her bone, she had to give it actually to the pilot because people would not let her go through security with her bone in her hand. So ever since then, I have to say, I have a very special place in my heart for Melissa as the bone lady. So what are some common characteristics? Especially in foundation, we have a tax exemption for a reason. So we can take risks, so we can be innovative, so that we can create opportunities for people and programs that perhaps many others cannot. Perhaps the government cannot, perhaps academia cannot, or industry most certainly does not take risks. We feel that the foundation is given its privilege in order to be doing things that are a little more entrepreneurial and a little more risk-taking. So we have a tendency, because we have a short life, to look for things that are under-recognized, underserved, and definitely under-resourced. So, as a former chief financial officer, let's get down to the bottom line, right? Therefore, why don't we take a second to look at this? So Coulter and its partners have invested $152 million in the last 12, 13 years on 3 programs: Translational Partners 1, 2, and then CTRA, which is basically young investigators, and early career. As you can see, for $152 million over a 12, 13-year period, we have gotten back, or our projects have gotten, over $3.3 billion in professional funding. Now, what I call professional funding is not government financing, or SBIRs, or STTRs that you may be familiar with from America. What I call it is venture capital, angel, things that can be audited, that can be publicly recognized. One thing that did come as a surprise to me, because we didn't plan on it, was that people who did translational research actually did better basic research, and therefore they were able to bring in additional money because of their translational research project, more money from NIH, which carries an overhead of 60%. So Coulter research teams actually brought in more government funding than they did as basic researchers. So we have in total 180 startups, venture capital angel finance, 118, licensed to industry, 48, and then products and services that are in the market today that's passed the FDA are about 43. So if I've gotten your interest, let's talk about how we did it. So we had a grand experiment. As Melissa said, when I spoke at a first, I don't know if you know, AMBI, is American Institute of Medical Engineering and so forth, people asked me, what are you going to do, Sue? They've been asking me for years. I have been going to the Whitaker conference, and I said, well, I think I'm going to do translational research. I practically got booed off the stage. That was in 2002, 2003, and I made up my mind that I would never speak about my program again until this program could speak for itself. So why do we translational research? Because, simple thing is, we want to benefit patients. Of course, basic research is important and needed, but until it benefits patients, it is a long, long time. And Coulter was a translational research company. We took an invention, the Coulter Principle, we embodied it, many innovations. which could directly impact patient care. Now, why academia? I had several choices what I wanted to do. I could have established 1 or 2 Wallace Coulter Research Institutes, but that would have been 1 or 2. I thought about funding translational institutes that already existed, Whitehead, Salk, Scripps, but there's only like 5 or 6 in the country. And then I thought, what about the universities? If it works, there's over 100 biomedical engineering departments in the country. If it works, I would certainly have a greater opportunity for excellence and impact. Why biomedical medical engineering? As Melissa said, when Coulter came on the scene, Whitaker was leaving the scene. And I always say to everybody, if Whitaker had not done what they did, Coulter could not do what they are doing. They set up the infrastructure. They set up the departments. Their monies funded the recruitment of faculty. They funded the instruments and the equipment and the laboratories and the buildings that came for biomedical engineering departments around the country. But at the time, industry had no idea what BME was. BME didn't have any idea what they really could do with the degree, so there's quite a doubt. So we felt the biomedical engineering degree is absolutely the degree for the healthcare industry. Every other time, if you have a mechanical engineer and electrical engineer and they go into healthcare, you have to teach them human anatomy. You have to teach them biology and chemistry, physiology. Ladies and gentlemen, the number one, that's not easy, and number two, it takes a lot of time. And the one thing the industry does not have is all the time to market. So when I heard about this biomedical engineering degree from Peter Katana, the president of Whitaker, I said this degree will shorten time to market. And why partnership with industry? Partnership with industry at that time was a dirty word. Commercialization was a dirty word. Development was a dirty word. But at the end of the day, if there's an invention or innovation in the academic laboratory, unless the university is going to manufacture it and sell it and market it and service it, you have to have an industry partner. It could be venture capital, it could be angels, or it could be industry, but you have to have somebody that take that invention and innovation out of the university. And because I come from industry, I understand that it's really important to find the right partner. So why translational? As we said, of course basic research is important. Without basic research, we wouldn't be going anywhere. But at the end of the day, there are so many inventions and innovations from basic research, and we need to translate them so they can truly benefit patients. They are what makes it possible to be bench to bedside. And commercialization is the only process that results in these innovations and inventions serving humanity. So why translational research the way Coulter described it? We brought the clinician to the team. And why is that? Because no one lost a patient today except the clinician. So no one understands a sense of urgency more than a clinician. And then if you think about it, who's the first customer? It's not the patient, it's the clinician. If your clinician does not describe or prescribe or write an order, is the patient going to have access to that technology or that medicine? So if you have the first patient and the user of that technology on your research team, the research will go much faster since he knows about the patient issues already. So we decided to bring in BME because, as we all know, engineers solve problems. And the BME is equipped to solve problems in healthcare. And academia, we felt, had the research infrastructure. You have your manpower, which is your students and your postdocs. You have the laboratories that's been equipped by NIH funding. You have your Office of Technology Transfer, which is essential in moving your inventions and innovations out of the university. And of course, industry brings the commercialization enterprise. They will bring the manufacturing and the sales and the distribution and the service to your product. So, why biomedical engineering? Certainly Wallace was a pioneer. He applied engineering principles to solve medical problems. And what degree in their title do you already know what career you want to have? If you're an electrical engineer, you don't know what industry you're going to work in. If you're a mechanical engineer, you don't exactly know what job you might have. But if you're a biomedical engineer, you already have committed to improving people's health. You have already committed to making sure that you impact people's lives. What better title than that? So why biomedical engineering? I want you to know at the time that we established our programs, the department was really, really new. It was so new, in fact, that it wasn't started by biomedical engineers. Most people who started a biomedical engineering department were engineers from aeronautics. And they understand risk, and they definitely understand innovation. So another reason we picked BME, to be candid, is the newest discipline. It's only about less than 50 years old. Mechanical and electrical is over 100 years old. And because it was new, it really hadn't been steeped in politics and tradition and bureaucracy yet in the School of Engineering, and it was young, and it was nimble, and it was flexible. And then the research of biomedical engineering, to be candid, would even interest Wallace, because it's everything, and it's anything. And the breadth and the depth of the human body, as you know, is challenging. Everywhere, any country, any place, at any age. So, another thing about medical engineering, when it was described to me, the characteristics of biomedical engineering, I said, wow, I spent hours in a management meeting at Coulter, and we have manufacturing, service, R&D, and we all speak English, and nobody understands each other. And I'm sure you have that at the universities too, as well as in companies. I find that the biomedical engineer are multilingual and multicultural. They can actually translate. They can translate from if you talk about it, the medical conditions of the patient and the clinician to the company. They can translate within the company and interpret what is research talking about in reference to marketing, and what is marketing talking about when they need something manufactured because they're an engineer. So I really have to say, I find a biomedical degree just stupendous. That's why I invested in it. And another reason, biology, medicine, and engineering. When I went to one of the last Whitaker conferences, a General Electric executive stood up and said, "What on earth is a BME? Are they half an engineer or half a biologist?" Well, today, I think the question has been answered. The biomedical engineer today is either number 1 or number 2 in the best paid jobs out of school. It is also more than any other engineering discipline, is more than 50% enrolled by females. Now, why is that? Why is it that electrical and mechanical can get 10, 12%? And biomedical engineering gets more than 50%. When we started our program, it was about maybe 12, 15. And now in every school that we know of, biomedical engineers are surpassing all the enrollments of any other engineering discipline. That is healthy. As we say, diversity, whether it's racial, ethnic, or gender, is healthy for business. And at the end of the day, if you don't have to teach an engineer about the human condition, it will definitely shorten time to market for industry. So, why partnership with industry? Our goal was by implementing industry's best practices that I knew from Coulter, it would accelerate the translation of innovations into practical advances that improve patient care. Because at the end of the day, ladies and gentlemen, all the research and work that you do, is it not to help people? Is it not to improve their lives? Is it not to extend their life or to save a life? So we had 3 experiments. We had TP1, which was for the universities. TP2, each of them were only 5 years. One was 2006 to 2010. The Translational Partners 2 started 2012 to 2016. But I felt bad that I only had an institutional program, so we put in place the Research Awards, which was an early career, young investigators, and that went for 8 years. So the infrastructure that makes it work, we have to have a principal investigator, has to be the department chair. That department chair has to be a champion for translational research in the university. It has to cross the borders to the School of Medicine and the VP of Provost, the senior administration, and so forth. But that department chair had access to $100,000 that was to be used at the discretion of this program, to get FDA consultants, to travel to conferences, to get together with other people and share lessons learned and best practices. The position of the Coulter Project Director was new to the university, and we recommended, where possible, to bring in somebody from industry because they understand the industry process and the pitfalls needed. But they should also try and understand in the academic environment and how does it work, and how do you cross the indivisible divide from the School of Medicine to the School of Engineering, and so forth. The Oversight Committee you will find interesting is that, of course, most of you have advisory boards. Our Oversight Committee was only clinicians, entrepreneurs, industry, venture capital, and members of the Office of Technology Transfer. Because the magic in selecting a project is the magic knowledge of the selectors. And if you want commercial and translational projects, you need commercial and translational experts at the table. And we also needed the old Office of Technology Transfer because they're the ones responsible for getting it out of the university. So some of the universities, when we went there, their Office of Technology was not well funded, not well staffed, was considered to be a cost enterprise. By the time our programs were through, they even changed their names to Office of Commercial Development, or Office of Development Opportunities, or Translational Opportunities. And they were then known to have the network of VC organizations, network of serial entrepreneurs that they could put in charge of their startups, network of industry organizations and funders that they could bring in to look at their technology. So you need a well-resourced, well-educated on commercial analysis, budgets, FDA, reimbursement type of issues in your Office of Technology Transfer if they're dealing with healthcare innovation. So you can't see this very well, but basically it's a roadmap to de-risk. What is the goal of the Coulter program? Our money, I guess you'd call it translational money, was what people call the valley of death. Most people have NIH for basic. And then later on, there is money for clinical research once the industry takes it out. But where's the money for the proof of principle? Where's the money for the proof of concept? Where is the money for the valley of death? Coulter was that money. So basically, it's a roadmap to accelerate and increase the commercialization of university innovation. And the whole process is to de-risk it all along the way so that we could get follow-on funding for the project. Because if you don't get follow-on funding, at the end of the day, you can't get it to the patient. So we go back to this again, and with the investment of $152 million, about 13, 14 years, we were able to get professional funding of $3.3 billion and $428 million of additional government funding. And the government funding is really important, and it was quite a contribution, which I had not planned, because government funding brought in 50 to 60% overhead, and the Coulter program only covered 20%. So at the end of the day, innovation in healthcare saves lives. And it is really a pleasure for me to be here. We're a country united by politicians and academicians and industry and so forth, are all dedicated to Sphere, who's dedicated to translational research and the process to save people's lives. And I'm delighted and honored to have been here today.